Hi, I'm Rich with Inside HPC. We're here at the Intel HPC Developer Conference, and I'm here with Prabhat from NERSC. Prabhat, welcome. Why don't we start at the beginning? What is your role at NERSC?
Sure, thanks Rich for the invitation. I lead the Data Analytics Services Group at NERSC, and our job is to create the data stack, get it to work well on our machines, work with vendors like Intel and Cray, optimize it, and address the requirements of a user community.
Okay, good. Well, you gave a plenary today. I thought it was kind of a compelling subject matter. It was applying AI to science. Can you tell us more about that?
Sure. Yeah, the plenary was a comprehensive review of all of our results in deep learning as applied to science. So I started off with characterizing how deep learning fits into the broader data analytics strategy, our users and what they are asking for, what we are trying to do in the hardware space, and then how we are working with Intel on software optimizations. And then we went into a few use cases. So clearly we started with climate with Michael Weiner. We talked about how deep learning can be applied for finding extreme weather patterns in climate data. Talked about cosmology, astronomy, neuroscience, high-energy physics, and genomics.
And can I ask you about some of the results? Because you had like an outstanding benchmark, as I recall, about 6 months ago. Can you tell us more about that?
Sure. So the 15 petaflop result that we obtained a few months ago is obviously being presented here at HPC DevCon, but also at Supercomputing on Tuesday morning. I think personally what was most interesting to me was that was not a synthetic benchmark. We took a real science application in climate and also one in high-energy physics. And then we used a production framework like Caffe, and we worked with Intel to optimize it on KNL. So in particular, we ran on 9,600 Knights Landing nodes, and we obtained around 2 teraflops per node and 15 teraflops overall. So it was a tour de force, I would say, on the software engineering side of things, just making sure that everything would work. But there were also some innovations on the deep learning architecture. What's the right architecture for these science use cases? And then once you run at this scale, which no one has done before, what breaks? How do you fix it? So there were some innovations on that front as well.
Well, I want to double click on that a little bit. On how does Intel help you with this kind of work?
Sure. So clearly, they're a top partner for us along with Cray, and we have 9,600 Knights Landing nodes, and who better would understand KNL architecture than Intel? So at least in the context of that collaboration, we worked with researchers from the Parallel Computing Lab, from various product groups, and we really optimized Caffe's performance on a single node. Once that was in control, then we worked with the MLSL team based in Russia, and we figured out how to get the communication going between different nodes. So I would say that a number of aspects, a number of different groups in Intel, the Parallel Computing Lab, the MLSL team, the MKL team, were really quite critical in making this happen. More broadly overall, if you think beyond just deep learning, and there are many different deep learning frameworks to optimize, like TensorFlow and Torch and Theano and so on and so forth. But more broadly, the data stack is quite large, and it includes other technologies like Python or Spark or R, also data management technologies. So again, we work closely with Intel on optimizing all of those.
Just kind of a wrap-up question here, Prabhat. In terms of the future, what gets you excited about where AI is going, with you guys being on the edge of what can be done at scale?
Yep. I think there's just so much to do in AI, and I think the unanimous agreement across the board is that we're just getting started. So I think we're yet to characterize what the limits are of AI, how much more we can enhance these architectures, what new problems we can solve with it. To me, I think personally, the exciting part is that there are a lot of cool challenges to work on. We have no characterization of the theory of AI and deep learning, and that is going to be important for science going forward. Certainly, I think the engineering challenges are there, and I'm sure that as we did with the 15 petaflop result, we're going to address them as we go along. But I think the core challenges pertaining to theory, I think, are really quite exciting for me.